let's do the review for your exam 3. So for your exam 3, we will cover what? Integrals. We have definite integrals, indefinite integrals, right? Then which include what? Some basic skills to integrate things. Simple, one variable things. And or you have multiple things, then we need to use advanced skills, which is what? Integrated by substitution or parts, right? Also, we do partial derivatives for more than one variable. For x and y, you do, del x or del y. For first level partial derivatives and second level partial derivatives, right? Then we use d-test for determining maximum value or minimum values. And we are also going to do some apps. So let's see, find the integration. So let's do the integration first. So like this one, this is just a simple integration, right? One variable and simple kind, right? So we always write it in what? Poly. So that would be 3x to the negative 5 dx, right? Then we have what? If you just do dx for x to the nth power for the polynomial, then n is not what? For derivative. So let's see. Then that will drop one level at xn minus 1, right? Then if we do the opposite, x to the n dx would go up one level higher, right? Indefinite integral. So you would do what? N plus 1 divided by n plus 1. However, under this condition, n cannot be what? Negative 1, because the denominator cannot be 0. Right? So for the power rule for the integration, just up one level, but the power is not negative 1, so we can do that. Then with constant, we do constant multiple, right? That would be your negative 5 dx. That would be one level higher, would be negative 4 divided by negative 4, right? Plus your arbitrary constant for the indefinite integral. So the answer would be what? Put the coefficient out the front, right? You can write it just like that, x negative 4 plus c, or you can write what? Negative 4x 4 plus. Either way would be fine, right? Then for the second one, so because it's only second power, you can just multiply out. That would be x 10th plus what? 10x 5th plus 25, right? Then times x, so we'll have what? X 11th plus 10x 6th plus 25x, right? Then you use the sum and difference rule. Oops, that's dx. Right? You do it individually. So this one would be 12 over 12 plus what? 10x7 over 7 plus 25x. Right? So, oops, where is my x? This one x times this is x. That's x squared divided by 2. Right? Then plus your arbitrary constant. So you can write it this way. 10x7, 7 plus 25x squared over 2 plus c. That would be your answer. Right? So we just practice the simple integration for what? Polynomials, and either negative power or regular powers, as long as the power is not -1. Okay, and let's take a look for the exponential function. So if we say derivative of exponential function is what? E to the x, right? And if you have some other constant, you have to use the chain rule for the derivative of kx, which is k. So you move out from would be this, right? Then if you have integration ex dx simple one, that would be just like this, right? Then if you have kx dx, what do? Then you divide it by k instead of multiply by k, right? Opposite of the derivative is what? Integration. So this is a simple one. What do? We just do the ex, follow the rule, divided by 8 plus c, right? So that would be your answer. So we are doing what? Indefinite integrals. And for polynomials, for exponential, if you have e to the negative 0.1x dx, it's the same thing, right? So e 0.1x divided by negative 0.1, right? Then what do we have? Divide, so that would be 1 divided by 0.1 is what? 10, right? E negative 1x plus c. So that would be your answer. If we have this bunch of them, x9 plus x plus 1 plus x negative 1 plus x negative 2 dx. So all the things are polynomials just like those, except what? -1, because we cannot do the -1. Okay? Who takes derivative become -1? Remember that? So we have, if we take derivative of natural log x, that will be 1 over x, right? So you do the opposite, that will be your x negative 1. If you do x negative 1 dx, you should go back to your log, right? But we say we use absolute value, because inside of log has to be positive. So then we do it individually. This one will be x 10 divided by 10. This one will be, excuse me, x squared divided by 2. This is x0, 1 constant, so that's x, right? Then this one will be what? Natural log of x. This one level higher, 1, -1 over what? -1. Is that right? So you will write your answer, everything pretty much the same, except this one, you will write a negative x1 power, right? Pretty straightforward, right, for indefinite integral. So then let's do some definite integrals. For your number 6, you have graph like this. Then you want us to do from -3 to 1. Find the area underneath the curve, right? And this curve is what? F of x equals half x squared plus x plus 1, right? Excuse me. Okay, so we say area underneath the curve from where? From here, -3 to 1, right? Excuse me. And so we say area under the curve is the same thing as what? Definite integral from if f of x is positive. Okay, so you just write f of x dx. We say area under a curve is the same thing as the antiderivative. Excuse me. We say the area underneath the curve, area is the same thing as the antiderivative of the curve, right? They mean the same thing. Then we use the area to find the average, to use this concept to do that. So what do? We do the definite integral, right? Then which will be what? Divided by 2, that would be 1 level higher, x cubed and 4, right? Then this one will be x squared over 2, this one will be x. Then we do definite integral. We use what? Fundamental theorem of calculus by this kind of symbol. Then we just plug in the symbols then to find the values. Is that right? Oops. This is a 3, I should divide it by 3. So I better write it out. So that way. Right? Then we plug in 1. So what do we have? 1 over 6 plus 1 over 2 plus 1. Right? Minus plug in -3. So what do we have? We have 3 -3 cubed plus -3 squared 2 plus what? -3. Is that right? Then what do we have? You just do your fractions, or you can use calculator if you know how for the fraction. Right? Then that would be 3 and 5 there. Then you add them. So that would be your answer to practice what? Definite integrals. Right? Let's have a look at the next one. Okay, so if we want to find the area between the curves, so we have one here, right? And another line is this way. So we have this line, -1, 2, we have -2 here. Okay, so we have another line like this. And we want to find the area between -2 and here. And also, this is the area we want to find between here and here, the area between two curves. So, which two curves we are talking about? Right? One is this one. So the function is what? Y equals x squared divided by 4. And another one is this one, right? So this equation is what? X. This one is x equal -2. Then this equation is what? Y equals x. So what are we looking at? We are looking at the area between this and this, right? Then x minus 2 is just your x reference from here to the 0 point. So what do we want? How do you write your integral? So you are going to do what? From -2 to 0. Then you do the two curves. Then you use what? The positive one, top one minus the bottom one, right? Two equations. So top one is what? X squared minus over 4 minus what? Y equals x. That's how you will write your integral. Is that right? So you take a derivative of that. That will be what? That's your 1/4. That will be x cubed divided by 3. Right? This one will be what? X squared divided by 2. Is that right? Then you have -2 to 0. Then you plug in your 0 and -2. Right? So it's what? 1/3. You should be able to plug in and use your calculator. So if the answer, we provide for you for the reference, if you don't have 1/3, then you can find the decimal. It's about this number. Okay? Next one. Okay, so we are still doing what? Practicing the integrals. Definite integrals and indefinite integrals. The basic skills. With basic skills, just simple polynomials then or exponential functions, right? Now let's do some more advanced integration. So if the individual one you can do the antiderivative, you are fine. But when you have things multiplied together, that will be difficult, right? You cannot just use the simple basic rules. So when you have multiplied together, you need to take a look, and if the inside of this x6 minus 7, right? Usually we just write a what? To the power, right? Then because the things are multiplying together and we cannot use the simple rule, so we have to use the chain rule or substitute. Okay, because we can see if I do dx for the x6 minus 7, then I will have what? 6/5 power, right? So that will match with this. So what can we do? We can use what? This as u, right? If this is a u equals what? U equals x6 minus 7. So you d to the du, take a derivative, it's the same thing as you take a derivative of x, will be what? 6x fifth power dx. Right? So we take a du already, so that will be du. Then what else we can do? So that's your u. Then we are going to integrate according to the u instead of dx, right? So what do? We have to find the du. So what's your du? So the remaining will be your du, right? But here is just 6. So if 2x fifth dx, then that will be what? Du divided by 3, right? You divide both sides by 3. So that will be your remaining things inside the integral you can replace it with, right? So you will end up what? You 2x and this 2 becomes what? 1/3 of du, right? And this one is what? U to the half, right? Then we take this is our original u to the half power. Then we take integral of this. Then what do we have? Then up one level, u 3/2, then divided by 3/2, then times 1/3 outside constant multiple rule, right? Plus your, then divided by 3/2 is the same thing times 2/3, so that will be 2/9 u to the 3/2 plus c. And we have to put it back. The u is this one, right? So your answer will be what? 2/9 x 6 minus 7 to the 3/2 plus c, right? Mm-hmm. So we did what? Definite integrals and indefinite integrals. Most of them were basic ones, right? Then last one we did was on your page 3, we did a little bit advanced one, and it was integrated by substitution. Okay, now look at your page 4. We started to do more complicated one with integrated by substitution first. Then we do the integrate by parts, okay? So when you look at this, then what did you see? You have things multiplying, right? But for the 8th power, it's almost impossible for you to multiply 8 times, right? It's not like your example 2 on your page 1, you have this one. Then it's just a square, you can just multiply them out, then multiply by the x, then you can do the simple integration for the polynomials, right? But this one 8 times, almost impossible for you to do that. So, what do you think? Do some observations you realize then 8th power, right? Then inside here, x cubed, if you take the derivative, would be what? Something to the x squared, right? So if so, because by the chain rule, multiply this would be this, so you know you can use what? Substitution, right? Because the chain rule inside of this just happen to be those for the x squared, right? So you will make the inside u equals what? 7x cubed minus 3, right? Then your du would be 3 times that, 21x squared, and dx. Is that right? Okay, if so, the thing is we wanted to do is this part. So that's this part you wanted to get it by itself, right? So what do you have? You will have x squared dx becomes what? Du over 21, right? Then what do we have? We will replace this by u, right? So you have u to the 8th power. Then x squared dx will be replaced by du 21 over 21. Then constant multiple rule, you take 21 outside, you can do that. u 8th du, right? Then you make the complicated integrals become a simple integral for the 8th power. So you can do that. So what do we have? We'll have 9, okay, one level higher, divided by 9, 121 plus c. Right? Then you have to put it back. So what do we have? Then u is this, right? So 21 times 9 will be your 189. Then u is this, 7x cubed minus 3 to the 9th power plus c. Right? Relatively straightforward. So we are practicing the advanced integral, a little bit advanced by substitution. Okay? So if you can do substitution, integrated by substitution, you do that. If it's still more complicated, then you need to use integration by parts. Right? Then for this one, what do you think? Do some observation first. You have what? A quotient. We cannot do a quotient, integrate a quotient, right? But you can see if you take the bottom, take derivative, that will be it happens to be what? 7x6 power plus 5x4 power, right? So you got some idea, you say, okay, I let my u equals x7 plus x5, right? Then my du would be what? 7x6 plus 5x4 dx, right? Then you can see this portion just like that, right? So you will replace by what? U is here, right? Then top whole thing is what? Your du, right? So that would be what? Your u negative 1 du. Remember, how do you integrate your negative 1 power? You cannot move 1 power up divided by 0, right? So that would be what? Natural log. Because your d dx, natural log of x is what? 1 over x, right? So equals what? X negative 1. If negative 1 take a power, take an integral, you should go back to your natural log. So that would be your u plus c. Right? Do you leave answer that way? You can't, because we will integrate by what? X, not a u. So you have to put it back, So that would be natural log x7 plus x5 plus c. Right? Manageable, right? For the integrate by substitution, you should be able to manage okay. Next one, we are going to do integration by parts. Okay? So, because if you take e negative 6x power, it would be what? If you take d dx e to the negative 6 power, it will be negative 6 e to the negative 6 power. But you still have the x, you have to manage to incorporate with it. Okay? So this is a more complicated situation. You cannot do it. Then you need to go back to do the integration by parts. Okay? And which is on your section 3.5. So we need to use section 3.5 for integration by parts. Okay? That's on your page. Let's see, which page is that? Page 86. So we need to use the page 86 integration by parts. Okay, the formula is what? Integrate u dv equals, let's write it out. Okay, uv minus integral of v du. The idea of doing that, because v du can be integrated easily instead of a complicated one. Okay, then let's take a look at your guideline on your page 87. And on your page 87, right? Because you have one exponent, one with poly, we say the rule of thumb is what? When you have exponent and exponential one and the poly one, you will set up what? dv is the exponential one, then your u would be what? The poly one. Okay, that's on your page 87, the direction. How to do the integration by parts. Okay, so first we will write it to the power style. So it's x e to the negative 6x, right? Then according to the guideline, what we will do, we will set up x as the u equals x. Then we set up dv as the remaining. dv is an e to the negative 6. Because individually you can integrate them, right? So we need to do this, right? So we need to find what? du. Du is dx, right? From here, we need to find the v. Integrate this for the e to the x kx. That would be what? So you take integration of this. That would be divide. So e to the negative 6x divided by negative 6. Right? Okay. Then what do? We will use the formula, right? Replace the integral of u dv become v du. Okay, then we multiply u and v, right? uv. So x times e negative x divided by 6 minus integral of v du. V is this guy. And du is what? dx. Is that right? So what do we have here? Negative 16x e to the negative 6, right? Then take the constant out would be what? Plus 16 e to the negative 6x dx, right? So you make a complicated integral, two things multiplied together becomes what? Simpler integral here, so we can resolve this one more easily, right? So we have negative 16x e to the negative 6 plus 16. This one, do it again, negative 6 e to the negative 6x, right? Plus c. Okay, so what's our answer? Will be negative 6x e to the negative 6 minus 136 e to the negative 6 plus c. Right? Are we good? Okay, so we practiced the basic integrals and advanced scale integrals, right? By parts and by substitution. So on your next page 5, number 12 and number 13, we are going to skip them. Those are integration by parts. Quite complicated for you. But if you wanted to do it, the answer is on your answer key, right? You can look at it. So one is this, one is definitely integral like this with log. It's more complicated. But if you wanted to take more calculus, you probably wanted to practice those, okay? But those are not on your test. If we can do this for our model, for the apps, that will be good enough for the purpose of this class, okay? So your test will be more, simple one like those for the integration by parts. Next one. So we did the integrals. Now we are going to practice some more partial derivatives and d-test, right? Partial derivatives are for more than one variable, right? So the second derivative, first derivative for the del. So if we have this one, we have two variables, x and y's, then result is z. So we have map x, y to the another things like that, right? So So that's our function. So this one is actually is what? fxy. Okay? Then we say for those, you have to see the xy would be your what? Domain. Right? To your z would be your range. Then domain has restrictions depend on situation like this, right? We say what? It's a fraction, then denominator cannot be 0. You only learn 3 types of restrictions. One is the denominator cannot be 0. One is what? The even rule, inside of the even rule has to be what? Okay, you learn 3 types restrictions. This one, x cannot be 0, right? Then if it's the even radicals, and inside of the radical has to be what? Positive, to take an even rule, right? And another one is what? Inside the log has to be positive, cannot even be 0, has to be positive. So those are 3 restrictions when you do the function. Same thing apply, you need to apply them to do the 2 variables. So we are asking you what kind of restriction they are. Right? You only have fractions. Then fractions cannot be what? The denominator cannot be 0. That's only one restriction. That is what? Negative 8y plus 9 cannot be 0. So you have to figure out what's your y. Y would be what? 9/8 to be 0. So you cannot be that number. Do your solving linear equation. So how do you write your restriction? We say domain is such. Okay, we are talking about what? Both x and y at the same time for the domain, right? Then you put a bar there, write down your restriction. Then all the x, y's are what? Are real numbers we are dealing with, right? At the same time, y cannot be 9/8. That's how we write the restriction. Then we put the curly there as a set, formal symbol of math. Then you write your restriction for the domain this way. Okay, so when we do the del things derivative for the second derivative, first you have to decide what kind of things you can use, right? That would be your domain, and see any restrictions there. Then we do the partial derivatives. So look at your page 6, number 15. We have 2 variables. Right? We want to find the first level, first derivative. Del f del x, del f del y. Right? So this one, take a derivative against what? X. So treat the y as constant. That is what it means. So take toward x. So 4th power, move to the front and drop 1 level, right? Become 3. But the inside is not only x, then you have to do the chain rule for the del x again for the inside. Right? Then what do we have? Then you take a derivative of this. That would be 4 times 3 is what? 12, drop 1 level, right? So that would be this guy 4, 3x fourth, 2y7 to the third. This one will be 12x cubed. Then treat this as a y as a constant, right? Then put it together. That will be 48x cubed, x fourth plus 2y7 to the third power. Is that right? Then we do the same thing as for y, right? Drop one level, 3x fourth plus 2y7. But for the chain rule, del y now, 3x fourth plus 2y7, right? Then, let's see. This is the same. Then you take a derivative for y, treat x as a constant. So that would be what? 7, 14y6, right? Then we clean up, multiply together would be what? 56y6 power 3/4 plus 2y7. Is that right? Where's my, that would be, oops. Take a look, typo. Okay, so drop one level, drop one level, drop one level. Right? I wrote it in a hurry, then I forgot about that. So just slow down as you do it, then make sure you cover everything. Right? Okay, next one. What are we doing? We are practicing the partial derivatives. All right, this one just use what? Power rule and the chain rule with respect to the separate variables individually at a time. Okay, so next one, let's practice some logs. Oops, I was thinking, oh, if I write that, take a look. This one, how many variables in there? 3. So I need to write it like this. Right? I have 3 variables mapping to the result. The range would be the 4th variable. So we are in the 4th dimension in here. Okay? So we are going to do the partial derivative fx. Okay? So for this one, we just do the x. So we treat the remaining as a constant. So for the log, for the x, you do what? 1 over, right? For the, because dx would be what? Natural log x, that would be what? 1 over x, right? So you do 1 over x, but inside it's not the simple x, so you need to do chain rule del x. Again, x squared minus y cubed plus z4. Then treat the remaining as constant. Then just deal with the x. So this one will be what? 2x. Right? So 2x times this would be 2x over x squared minus y cubed plus z4. So that would be your answer. Okay, so we did what? Partial derivatives. We reviewed those. Then we do some apps. Okay, on the problem 12, for this one, there are some typos. I had what? 2t half dt. I wrote something like that, but actually it should be negative 2t half dt. Okay, and we are going to skip 12 and 13, but if you are interested, then figure out what was the typo, you can fix it. If you have questions, and text me, then we can talk over. Okay? So, let's take a look some apps. On page 6, let's do number 17. Okay? Business total savings. A company installs a new computer that is expected to generate income at the rate of 20,000 E times negative 0.02 T dollars per year. Okay, that's your rate. So rate is 20,000 E to the negative 0.2 T dollars per year. So first year you generate how many dollars? Second year, that would be the rate. T is number of years that computer has been in operation. So if the computer originally cost $120,000, okay, when we pay for itself, round answers to the nearest tenth. This is a typical situation, right? You buy a copier or computer, then the machine will generate, say, saving for how much money. So it saves each year would be different, right? So continuously. Then you accumulate so many years, then we say you will pay for itself. That's a typical business saving, right? When they do the invest, then they figure how much the rate you can save for each coming years. Then, then total you will recuperate your capitals. Right? So, what do you think? It's just like, take a look at your page. Let's look at the page 77. 77, 78, 78. Okay, continuous stream of income. So this one is like your continuous stream of income, right? So your income for how many years? Then up to $120,000. Then that would be your total saving, right? So it means what? Pays by itself. All right. So you look at the page 78. So continuous stream of income, because the rate is continuously, right? So we use continuous stream of income. So your total, say, present value equals continuous stream of income is 0 to the T Ct E negative RT dt, right? For that one is what? Continuous stream of income is $75,000. So the equivalent value would be PV, right? So we use that concept. we say how many years you will accumulate becomes $120,000 as today's value, right? So that would be your total saving. So we say, okay, use that concept, your $120,000 to have a continuous stream of income, 0 to how many years? Say a year, right? Then that's the rate. If you take antiderivative of the rate, apparently they got a 2%, right? Each year for the interest. So you do that. That's the equation you need to write. Okay? Then up to 8 years. So let's see. You do the antiderivative for the what? Fixed integral, right? Definite integral. So you do antiderivative. That would be for the e, right? Over negative 0.02 and 0 to so many years. Okay? Then you plug in, that would be what? Divided by this would be negative 1 million actually. Okay? Then you plug in the definite integral to the e to the power. So that would be e to the negative 0.02a minus 0.02. Oops, that would be e to the negative 0.02 to the 0 power, right? I just divided 20,000 divided by negative 0.02. That would be my number. Then I plug in a to the t, 0 to the t. That would be my equation, right? This is supposed to be $120,000. Then how do you solve this? You need to know how to solve your equations by now, right? So you divide, so that's 120,000. Then I'm going to divide by million, okay? So try to solve for my a. So that would be negative 0.12. Then this one cancel off. So e to the negative 0.02a, e to the 0 power is 1, right? Then I plus 1, so I have 0.88 equals e to the 0, right? Then this is what? Exponential function, exponential equation. Then you need to solve your a. How many years? Right? Then in the first week, we learn how to solve the exponential equation. So you rewrite what? Log base e, right? Put the 0.88 inside. So that's your negative 0.02a. So that's how you do, right? To the e to the power is inside. Then this one actually is a natural log 0.88, right? Then what do we have? We have natural log 0.88 equals negative 0.02a, right? Then you plug in the calculator, find your a is what? About 6.39 years. So to the 1 decimal point, then nearest tenth, that would be your answer, 6.4 years. Right? let's look at the next one on your next page. Number 18, average. Okay. The rate of vocabulary memorization of the average student in a certain foreign language course is given by this dv dt, right? V is what? How many words per time equals this way, right? T is number of continuous hours of study. Is say if 1 hour, that would be 25 words. If 4 hours, that would be 10 words. That's what it means, right? And they study between 0 hour, more than 0 hour, to up to 4 hours. So that's how many words they can remember. And how many words will be average student memorize in 3 hours? We wonder in 3 hours, in average, how would they find it? Okay, so how many words would be average student memorize in 3 hours? So this is average student's ability to remember words. So what do we want to find? The question is find what? V equals what? Number of words, right? Then we want to find it in 3 hours. Then we know the rate, dv dt, is what? The rate of the words, memorized, right? That means this is your V, then the rate would be what? V prime of t. Is that right? So we wanted to find V, right, from V prime t. That's given, right? So to find the V prime t to V, what do we need to do? Then we know the integral of V prime t dt, antiderivative, that would be your V, because you take a V, take a derivative would be V prime, right? So we need to do that. So V prime t is your dv dt, the rate of words, which is this function, right? So you write it this way. So 50 over t plus 1 dt. But for 3 hours, what do? We do definite integral for 0 to 3, right? Once you have concepts correctly, right, then you can do the math. Then that will be what? 50, 0 to 3, 1 over t plus 1 dt. That will be your antiderivative for 1 over something. That will be your natural log, right? So that would be natural log what? T plus 1, right? Derivative t plus 1 just 1, so just t. We don't have to do chain rule. So we are going to do what? 0 to 3 for the definite integral, right? Then you plug in, that would be 50 natural log 4 minus 50 natural log 1 plus 0, right? That would be 0. Then you put it into the calculator. That would be what? About 69.3 words. So the answer should be around 69 words. That's how you use the integrals to solve your problems. If you have a model, if you have the model like that, Of course, you use stats, to do the survey, to check all the students, more than 31 students or something. Then you find the equation, the function for you to use. All right. Then you use your antiderivative integral skills to find the answer. Okay, let's see. Next one. Consumer surplus. The demand function for product is P equals 100 over 1 plus X, where P is the number of dollars and X is number of units. So it's a demand function. So what do we have? Demand function X is, P is the price, number of dollars. X is the what? Units, quantity. How many, it's sold, or how many is in demand. So demand function will look like what? The more quantity, the lower the price. The less quantity, the highest price. So the demand function usually look like that, right? That's our demand function. So for this one, you can look for the, market and demand. So that will be on your page 77. Take a look at that. Then it says the function itself is this way. P, the price, equals 100 over 1 plus X, right? That means if demand is 1, only one quantity is demand, it will be sold what? $50. If 2 and 3 will be $25, 4 will be $20, things like that, right? Then it says equilibrium quantity is 4. So we have 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So 4 at the 4 quantity, and it reached the balanced market. That's what it's saying, right? So if it's 0, that would be what? The price would be $100 according to this model. Okay, so it says the equilibrium quantity is 4. That means when we reach this point, it's a balance point. Market and demand balance out, right? So they will sell at this market rate. Then at a quantity of 4. If sell at this price, but some people are willing to pay more, right? Then so what's the consumer surplus? Then we say consumer surplus. Look at your page 77 is what? Consumers surplus will be calculated by what? From the 0 to the balance point quantity, right? Quantity is 4. Then you take the antiderivative of those. Then consumer surplus is when they reach equilibrium point, the area underneath the curve between this balance point, then all the things above it, the area will be the consumer surplus. Okay, so this is the price the customer is willing to pay, right? then minus this line, so at each point would be what? The extra surplus, right? Then if you take the antiderivative of this, that would be your consumer surplus. But how do you find this line? The area between two curves. Then what is this line? You have to find that equation. Equation is what? This one is P is that, right? This one is what? Your Y equals your price at equilibrium spot, which is what? Quantity is 4. So at the quantity is 4, then that would be your price for your Y, right? So you plug in here 101 plus 4, that means what? 20. At $20 and quantity at 4, that would be your market price at the equilibrium point, right? So you need to find the area between the curve, that would be your consumer surplus. Remember, the supplier's surplus would be like this, and consumer demand would be this, right? This would be your equilibrium point for the quantity, for the price, right? So you need to review your page 77, 78, things like that. So you minus this one, 20. That's how you set up the things you need, right? Doing it is relatively easy. You take antiderivative of this, that will be your natural log 1 plus x, right? And times 100, right? Then antiderivative, this is 20x. Then for definite integral, you need to do this from 0 to 4, right? Then you plug in, you find the answer. You will be around $80.94 for the consumer surplus. Okay? Take a look at the next one. So, suppose the income from an internet access business is a continuous income stream with annual rate of flow given by FT. FT, according to the time, is 90 T times e to the negative 0.5 T. Okay? In thousands of dollars per year, find the total income over next 10 years. Next 10 years. So continuous what? Stream of income. So you look at your page 78. That's how we calculate the continuous stream of income. This last time we did what? Each year it just make what? $75,000 income for next 8 years. Then we accumulate, see, you know, if they want to sell you $630,000, the business will be worth for you to buy it. That was on your page 78, right? Then for this problem, it's next 10 years, they have this model. Then on your page 77 or 78, it has what? Continuous stream of income, only fixed number, $75,000. So you plug in 75, you only have exponential function to deal with. But now the model, you have T and this next 10 years. More complicated. But the concepts are the same. Right? For this model, right, like Facebook, definitely there will be interest to have somebody hire somebody to figure out the model for them for next 10 years, what's their potential income for the continuous stream of income for next 10 years, how much they can make for each year. Then they find the model so they can plan their future, right? That's just a typical business world. I would think they would do that. So we'll use this formula to see, find the total income over the next 10 years. We will use this formula, right? Because you integrate means what? You adding all those numbers together, put it together. But still is called what? Integration. So what we want to do actually is a continuous stream of income for 10 years, right? You do your FT, DT, like those. Then, so 0 to 10, your FT is this one, continuous stream of income. Just like that, right? But the example on 78, you have $75,000 for fixed income. You only deal with what? The exponential function. To do it, it's easier to integrate. But when your model has something multiplied together, it becomes what? Much more complicated. Then we cannot use those simple rules anymore. Then what do we need to do for this one? For multiplication with polynomial with exponents, we say what? You will use the poly part as u, right? We use UD integration by parts. We need to use what? U dv and v du things. Okay, we use this as the polynomial part and dv use as the remaining part. Okay, e negative 0.5t dt, we will do that. Then this one we need to find the du, which is dt. This one we need to find the v. We take integral of this, right? That would be e to the negative 5t. With chain rule, you need to divide it by negative 5. Negative 0.5, right? Which would be 1 divided by 0.5, that would be 2. And negative 2e negative 5t. Okay? So it's more complicated. Then we have to use what? U, dv, v, du things. Remember that? Your formula u dv equals what? uv minus v du. Then u dv is complicated one. Then when you change it to v du, we become simple one. So we can integrate that one instead of original v du. Okay? Then let's see how we are going to do that. So we have 0 to 10, right? So we will do v du things here. Okay, let's take 90 out first. Then we have t, right? E negative 0.9, 0.05, 0.5 t dt, right? So that would be my u, that would be my what? dv, right? That's 0. Then what do we have? Let's do this one. So we will have uv, u times v, right? What's u? Here. What's your v? Here. So u times v will be negative 2 u times v, e negative 5t, right? minus this v du. V du. V is this one, right? V is this one. Du is this one. We have this. Du is dt. Okay? Right? And we haven't done the definite integral yet, so we're supposed to do from 0 to 10, right? Let's find the indefinite integral first. Then for this one to take antiderivative, that will be what? You take negative 2 out, then become plus 2, right? So we will have negative 2 u e, where is it? U, where's my u? Oh, my u is t, right? I was thinking what happened. So my u is t, right? Times e to the 0.5 t, take antiderivative, this will be plus 0.10 e to the negative 5 t dt, right? This is my inside, then I take an antiderivative of this, right? That would be my 90, right? So this one will be what? Oh, my 2 should be outside. Then this one will be, are you with me so far? 5t over what? Divided by 0.5, right? So what do I have? I will have 90, negative 2t e to the negative 5t, 2 divided by 0 would be minus 4 e to the negative 5t, right? That's integral with what? From 0 to 10. Is that right? So if I multiply them, I should have a negative 180 t e to the negative 5t minus 360 e to the negative 5t. Right? Then I wanted to do this from what? 10 years. Then you plug in 10 and 0, you will get this, okay? 360, you can do the math. Okay, so just to make sure you plug in, you actually can get this number. 360 minus 2160 over e to the 5th power. All right, so those questions are relatively, not difficult, not simple. First, you have to have what? Continuous stream of income concepts, how to accumulate the total in the future, then relevant to the present value as well. How much you're worth today. All right, and you also need advanced skills with what? Integration by parts to be able to do those. Right? Then integration by parts for definite integrals, then you need to know how to plug in the values, plug in 0 and 10 to actually find the values. Let's look at the next one. Suppose that the number of thousands of insects killed by 2 brands of pesticide is given by this function. So you have 2 products. So you have 2 variables, x and y. Okay? The model given to you is this one, 0.0, let's see, 0.4x minus 1000 e to, okay, somebody did a study, give you this model, exponential functions, right? X, Y are on an exponential position. And x is the number of liters, brand x. Then this is for brand y, okay? The rate of change of insect death with respect to the number of liters of brand x. We are talking about first product. If 130 liters of each brand are currently being used, so how many insects would be killed? Okay, by using 130 liters of product A. Right? So we want to find out the number of insects killed by these 2 brands are this way. But the question is, what is the rate of change? So how much more when you kill 130 use the product A, brand X, how many insects will be killed at what kind of rate? So when we talk about rate of change means what? The derivative. But for the brand X, we would do what? Partial derivative with respect to X, right? So you do partial derivative for x, what do you have? 0, then take this, will be negative 1000 times what? E to the negative 0.4 divided by, that's your x. Right? Then this one will be treated as constant. Then you have this, oops, we take a derivative, we are not taking the integral. So I should do the multiplication instead. Times what? E to the negative 0.04x. Right? So that would be what? It's 280 e to this. Then the question was asking if we put 130 liters of brand X and brand Y. So what do? We plug in the value 130 and 130, but just for X. So we plug in here 280 e to the what? 0.04 to the 130. Okay? Then plug into your calculator. So it would be 144 somewhere there, right? By the thousands. That means it would be what? 1,544 insects will be killed around there. That's how you interpret the question and evaluate them, right? So, one more thing, when we try to find the partial derivatives and for the maximum, minimum values, then we use what? D-test, right? So we need to practice one of those D-test things. So D-test for the purpose of relative maximum and minimum, right? Also have what? Saddle point. So how do we do that? So first, if one variable, we use what? F prime of x. Find the first derivative equals c, then we equals 0, then we find the x value for your critical numbers, right? Then second one is what? Use f prime prime for this number. See if it's bigger than 0, you have relative minimum, less than 0, you have maximum, right? Then if this one is 0, that will be indecisive, inconclusive. But you use this to find critical number. But if for more than 2 products, then we use what? We use f first derivative, right? Prime partial derivative del x to find it equals 0, right? And y equals 0 to find your what? xy. The first step, first derivative becomes 0 to find your x and y. Then second one, we use d test, right? We say if d greater than 0, d less than 0, d equal to 0. Like your second derivative, we use d test. If equal to 0, it's inconclusive, right? Inconclusive. If less than 0, then that point is a saddle point. Then greater than 0, you have 2 conditions. One is what? Maximum. One is a minimum. By checking of what? fxx. Right? That's your d test. Then which one, greater than 0 would be minimum or maximum? Take a look, your d test. But the d has to be greater than 0 to be one of these, maximum or minimum. Then d less than 0, you will have a saddle point. Okay, d equal to 0, you have what? Inconclusive situation. Just like your first derivative. We are doing the second derivative. Okay, let's see. Then let's practice some. So let's see if z is this one, 5xy squared plus 7xy. That means what? 3 variable, 3 dimension. So we are into the 3-dimensional situation for 2 variables given, right? We say for d test, then first we have to find the what? Critical numbers, critical points by fxx, just one level fx and fy, right? Then set them to 0 to find your x and y's. Okay, so your f of x is what? Take a derivative with respect to x, treat y as constant. So that would be what? 5y squared to x, that would be 7y. Right? Then for y, del y, take a y, treat x as constant. So take a y will be 2 10xy, right? Then plus this one will be 7x. Then we set them to 0, then see what happened. From here, you solve it. 5y plus 7 equals 0. So your y is what? 0 or y equals -7/5. You have 2 numbers, right? But your numbers, x and y's, have to be what? Satisfy 2 equations, both, okay? So for this one, you solve it. You take x out, would be 10y plus 7 equals 0, right? So your x is 0, your y is what? -7/10. So for this situation, because y is this, but the first equation said y can be those. So this one conflict that one, so cannot be, right? So x can be 0. That's fine. Make the equation be 0. However, you need to find your critical number is x and y and some kind of z, right? Z just plug in. So you need to find your x and y first. But you have x. Can x pair up with y? When x, we're talking about those critical numbers, right? So x is 0, y 0 will work. So you plug in. Y0 works here, but Y0 will not work for here. So you plug in 0, Y0, 0 plus 0, it's 0. So it works. How about this one? For xy, when x is 0, y is negative 7/5, will it work? So x is 0, then y can be negative 7/5, still working. This one is saying x can be 0 or y can be 0. When x is now 0, this still work. But when this one is this, conflicting with the previous y, so you cannot use. So you can only use x is 0. Then you look at this x, can it be paired with y? Yes, to make those both equations true. Okay, but all the critical numbers are x, y, and z. So for this one, x is 0, y is 0, what do you have? You plug in here, z is 0, right? Then for this one, x is 0, y is 0, y is negative 7/5. You plug in here, right? So that would be x is 0. That would be 0. So y is negative 7/5. You plug in, z is still 0. That's the critical points we are talking about for three-dimensional world. It's x, y, z, right? The question is what? Finding the relative maximum or minimum. Okay? Then look the answer. We have to decide those points are condition like this or a settled point. So use d-test, second derivative. So we have to do the d-test, right? Then we do fxx first. We do that to the xx is 0. Then fyy to do the y, so that's constant. That would be 10x, that's 0. Right? Then we do our fxy, fx is this. Then to the y, that would be what? 10y plus 7. Or we do fyx, fyx would be what? Fy is this, then do with the x. That would be 10y plus 7. Still same. Okay, they are usually the same. So the d is what? Equals fxx fyy minus what? fxy squared, right? fxx yy, that would be 0 times 0 is 0 minus xy squared is what? 10y plus 7 squared, which is negative 10y plus 7 squared, right? Then we decide d is greater than or smaller than 0 by doing what? Using the critical points. So we have 2 points at this 0, 0, 0, and at this 0, negative 7/5, then 0, right? Then we plug into d is here. Plug into d. Y is what? 0. So 0 plus 7, 7. So it's a negative 7 squared. It's less than 0, right? Then for this one, d is what? x is 0, y is what? Negative 10 times negative 7, 5 plus 7 take square. But whatever square is positive, take a negative, it's less than 0. Or you can just do it 2, negative 14, negative 7, take a square, still positive. Then negative, so less than 0. So what does this tell us? If d is bigger than 0, look at your section, which one? Your 4 point, let's just review right now. So for your 4.3, right? For your page 97, we say if d is bigger than 0, then your fxx, if less than 0, then you have maximum. If this one bigger than 0, you have minimum, right? That's on your page 97. However, for this one, both d are less than 0. That means what? It's a saddle point. So that means what? 0, 0, 0 is a saddle point. Right? Then for this one, less than 0, that means what? Same thing. 0, negative 5, 7, 0 is a saddle point as well. That's how we decide. Okay? Then you will have one of those questions on your exam 3. Okay? So this will be the last video we have for this class. So we have what? Review 1, review 2, review 3. Then we will have your final. Okay? Final, we will not do the review for final. So you will review all your review paper 1, 2, 3 to study for it. That will be all the videos we will have for this class.